So I want to introduce an analogy that's going to really help you visualize what's happening in circuits. And I call it my plumbing analogy. All right, so if you think of your home and how your plumbing works in your home, and some of you guys don't have an idea how it works, but hopefully you understand. It's a series of pipes that go through your house that give you water, right? So plumbing, or we can say it's a water analogy. Some people like to think of it, like water in a river as well. All right, but I'm going to tie some concepts together with this analogy, and I think it really helps you get your head around what's going on in a circuit. All right, so if you have a system of pipes in your home, well, you're going to have water running through those pipes. All right, so let's define, we have water in the pipes. Right, you're going to have the water flowing, right? So there's a flow of water. That's different than the actual water, right? Water can sit there. It's typically, the pipes aren't empty. They're full of water all the time, unless you lost your water supply. Then you hear that, kind of like the bubbling in the pipes when they refill up, if you've ever had your water turned off. But if the water is on, the pipes are full all the time, right? And so you get this flow of water once you open some of these faucets here. So let's define what the water would be in a circuit. Hopefully you would recognize, well, the water is the stuff that's actually going to make you wet, and that's the same as the electrons or the charge in a circuit. All right, so those electrons are in those metal conductors all the time, ready to be moved, and when they move, right, they're flowing, we have current. So the flow of water is like the flow of electrons, or the current. Now, we talked about what would make an electron move. Well, it's the same thing would make water move. It's water pressure, right? If you don't have any water pressure, you can stand under the shower and it's just kind of falling on you. You want some pressure in the pipes, right? So if we think of the water pressure, or the pressure in the pipes, we've talked about pressure in an electrical circuit. Well, that's our voltage. All right, so we've got charge, we've got current, we've got voltage relating to the water in our system here. Now, we also need something to send the water through our house, right? We need the actual pipes. The series of pipes that run through our home, the plumber comes in and fixes, right? Well, those would be like our conductors. They're the pathways through which the water flows, right? The conductors being the wires, right? So we need some kind of pathway that's going to allow that water or the charge to flow, right? So the pipes would be like our conductors. We need a way to turn the water on and off, right? We call these valves. Right, so that water doesn't flow until you open or close the valves in your faucets. And this is the same as in a circuit, right? We can have an appliance that's on or off. Well, we need to turn on the switch, right? So a switch in a circuit is like a valve for a sink or a faucet. Now, that water actually can flow through things in your home. You might have a nozzle that's, spraying, the flowers in the flower bed, or your shower head. So you have these things, maybe a nozzle, a shower head, maybe even like a kink in a hose, right? If I have a hose in the backyard, I'm sure you guys have all done this. You step on it, you kink it, and it stops the flow or slows it down. It's just trickling out the end. Right? These are things that are going to put a load on your plumbing circuit, and that's no different than having a load or a resistance in an electrical circuit. Right? These are things that slow or control the flow. You have to have a source of that water as well. And so some of you guys might say, well, where do I get the water? Well, I go to the faucet, right? The faucet itself can be thought of as one of two things. It might be considered a resistance or whatever, but It's a source of that water. Even the main entering your house or a spigot. These are things that supply the water, just like an outlet in your home supplies the electricity. Right? And then you can go a step further. There's a larger source where we get our water. Maybe like the town reservoir, or maybe a well in your backyard. That would be like a source of that charge. And we get that source of electrons typically from our local power plant. Right? The Pico substation is going to give us those electrons. Right? And so this analogy is not perfect. It does break down a little bit. And we'll kind of revisit this as we go. This is one way to look at how charge flows through a circuit, to think of how water is going to flow. But I also want to throw in one more analogy here, and I'm going to do this in red. And this is going to really help us as we move into more complex circuits. And so I'll hit you right now with this analogy, and so I'll kind of use them interchangeably. Another way to think of the movement of charge is think of how cars move through a traffic grid. All right, so I'm going to do another set. I'm going to call this our traffic analogy. And I can kind of explain and use them both interchangeably. Hopefully you would identify that the water in the pipes or the charge, the thing moving would be the actual cars in that system. The flow of cars, the current, would be like the traffic flow. Right, and obviously cars kind of have gaps between them, things like that. Maybe the traffic flow, we would say, if you put into Google Maps how long it would take to get from A to B, depending on how quickly traffic moves, they would give you a time, right? And you could determine an average speed, right? So this is kind of like the time from point A to point B in a Google Maps, right? Or you could say maybe an average speed. Because obviously, you know, you're going to have slowdowns, you're going to hit traffic lights, things like that. But the overall flow, the speed, would be from A to point B. Voltage is a tough one with a car scenario. It's kind of like how much you really want to get from point A to point B, which is kind of a weird analogy with cars. But you might be able to think of like traffic demand, right, as what would determine how quickly cars want to move through that circuit. Not a great one-to-one comparison, but traffic demand might be a concept here. The conductors of the wires would be like the actual roadways. You have some roadways that have multiple lanes, some are single lanes. That's going to allow different amounts of flow, and that traffic flow is going to stress those roadways more or less depending on the capacity of those roads, right? So you see the same thing with conductors. A switch or something that would turn on or off our traffic grid, I would say is more like maybe a road closure, a road or a lane closure. Traffic lights could be considered a switch as well because they can close down the roadway, but you can think of switches that way. A load or resistance, that's really more where traffic signals or speed limits might come into play. Traffic signals, speed limits are going to control the flow of cars, right? Maybe even like curves in the road. A really windy road is going to really control how quickly you can pass through it. The number of lanes. A nice wide road you can go a little faster through. Maybe even some accidents along the way. And one big one we're going to deal with in our analogy is something that controls the flow on highways. Toll booths. So we're going to talk a lot about toll booths when we start getting into different types of circuits and pathways. So these are just some different scenarios that compare, and obviously, where you get the cars from, that's just society. I don't think you need a direct one-to-one here. But we got a couple analogies now that we can use to make this idea of a circuit a little bit more relatable to things we already, I think, understand pretty well. How cars move through a traffic grid and how water flows through our plumbing. And so I'm going to reference this. It's important to know, and I'll reference this a lot. And if you really understand these relationships, I think it'll help you start to predict what's going to be happening in our circuits.